I think we're live now. Let me just get the YouTube confirmation. As usual. And once I get that confirmation, I will get going. So in the meantime, let me just set up the development environment here for you guys, because this is going to be hopefully a very productive stream. We're going to do a few problems. And I still don't have the confirmation. I still don't know what YouTube is doing. But anyway, so let's create... Ooh, no, this is not what I want. Hey, I think we're live now. But anyway, right? So let's... Hello, welcome to the stream, everyone. And yeah, this is a Monday evening stream. It's basically a routine now for the channel to have a stream on a Monday, where I'm kind of like least tired in the week. We got a little peanuts here, salted peanuts, best thing to do when you're coding. And to offset the saltiness of that peanut when you're like eating it, we got some Coke Zero. So yeah, delicious, delicious, delicious. Yeah, so let's get started. So I haven't actually done a LeetCode stream in quite a while. I think it's been like over 2 years since I've done one of these. And to be honest with you guys, I had no idea what to stream this week. And I wasn't really planning on doing some like research or anything like that. So I thought, let's just try and exploit the YouTube algorithm and put LeetCode in the title and do some LeetCode. And let's see how it goes. And I can see it already works because there's already like 5 people that tuned in for no reason. Just by having LeetCode in the title. So you can see, you know, how the algorithm is biased towards very kind of popular topics. So I've actually logged into my account here for the first time in like years and years. I can't remember the last time I logged into LeetCode. And I thought, let's maybe pick one of the easy problems here to start off. We'll finish that in 10 minutes and then we'll go to the next ones, right? Maybe we can pick a problem from a particular company. Maybe you guys in the chat can tell me what to work on, and I'm happy to kind of like try and work on whatever problem you guys suggest. But it will be C++ though. It will be C++. So I don't want to get the first one because that's probably like the easiest one. So let's get this problem here. And let's see what it's about, right? So let me zoom in here. I am absolutely not going to use the editor here in the LeetCode because first of all, it doesn't have Vim, does it? Yeah, it doesn't have Vim at all. And I would just prefer to use my own stuff, to be honest, which I've prepared here. So let's just create a CMake list real quick. Real quick. Let's see the fastest CMake list.txt ever. So we have CMake minimum required version 3.25 or something. Project LeetCode, languages CXX, and add executable. This is the fastest CMake list you'll ever see in your life. Actually, I forgot something, right? CMake CXX standard. Let's set that to 23. Why not? Yeah, 23. Why not? Let's do the same here for standard required, and we're gonna go for on. And we're gonna set CMake CXX extensions to off, right? Okay, so now we should be able to just do something like create a new file, main.cpp here. Can we select a variant? Can we CMake configure this? Yeah, it seems to be working, so we should be able to actually do our CMake or C++ code here. Right, so just out of interest, let's see if we can say hello world real quick just before we start with the LeetCode problems. World. Can I build? What the hell? What did I even press there? I just wanted to do a build. And yeah, but anyway, for those joining the chat, we're just like setting up the environment, the development environment real quick so we can start coding. We've got everything here. So we've got the LeetCode example. So in the terminal, if I just go to my build directory, and then go into main.cpp. Nope, sorry, into build. I have the LeetCode example, and it just says hello world. Good. So we are ready to tackle the first one, right? So you guys are going to help me here, and please don't be shy in the chat. Say hello. If I do struggle, you guys can kind of like help me out. Right, two sum. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution. Okay, so this is actually a fairly easy one to do, actually. You may not use the same element twice. Right? So you can't do index 1 plus index 1. That's what this is saying here. You can return the answer in any order. What do you mean any order? Okay, so it's either 0. Okay, so the target is 9, and we get this array. We're supposed to find the two numbers here that add up to 9. I get it. So 2 and 7 is the only one, right? So the ordering thing, is that supposed to be something like it can be 0 or 1 and 0? That's what I assume. It doesn't really explain very well here. So the target is 6. So 2 and 4 are the only one, which are indexes 1 and 2. Fine. Cool. So there are constraints. So the numbers.length. So the length of the array is at least 2 and up to 10,000, right? And then each number is basically, what is 9? A billion, yeah. So, I mean, it can fit in an integer, right? That's what this is saying to us here. So we can use an integer, a normal integer. And the target is anywhere between, is it an integer as well, right? Can you come up with an algorithm that is less than n2 time complexity? That's an interesting one, isn't it? Because when you do this for the first time, right? Let's get the Excalibur out here so we can see what the problem is. Oh, sorry about the mess here, guys. You know, you're coming into my home and it's messy. That's my Excalibur. So say you have something like, can I please just do some text in the middle? There you go. Say you have like 1, 10, 50, 40, 7, 8, 9, right? And let's get a quick thing here. Just some arrows so we can represent this. So my first thought on this algorithm is to start on the first index, right? So we fix that one, and we literally go through every other index, add up the sum, and see if it creates the target, right? So we want to find, for example, let's say we want to find 16, right? The target here is 16. So this algorithm would actually like be quite slow for that, right? Which would, you know, we start at 1 and then we fix that and we go to every single one here, boom, 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 haven't found it. Then we go to the second one here and we work out this here, you know, 10 and 40, 10 and 7, 10 and 8, and so on and so forth. Until you keep doing this until we reach the actual answer, which would be somewhere in here, 7 and 9. But this is O2 when you think about it, because we are, for every number, we are essentially or potentially checking all the other numbers as well. I mean, it does go down every time, right? Every time you complete a number, you're not counting that one. So, it, you know, it is less than O2, but I guess it still would be O2 in complexity time. Now, can we do it better though? So can we make some assumptions that would help us out here? So we know that the target is 16. And we know, I guess, that it has to be like something like A plus B, right? So these two numbers have to add up to 16, which means, yeah, no, they can't always be less than the target, because you can also have, I guess, negative numbers in this. So, Tell you what, let's do the naive answer and see if we pass that. And then if there's some inspiration later on, we can work that out as well. So I guess that solving this is actually quite easy, but getting the something that's better than O and 2 complexity is not as easy. But yeah, so let's just copy this. we're gonna paste it here, and let's solve that. So our input would look something like, you know, vector of int. What is it? Let's pick an example here. So this one here. We're going to include vector. Anything else that we need to include? No, that's it. Oh, let's sort these out. Okay, we've done that. We need to implement this, right? So what I was thinking of doing is something like very easy, such as int I or std size t. I is equals to 0, and then we iterate through every single one of the items. So I would be less than nums.size, and then we increment I every time. You know, fairly easy stuff, nothing too difficult. So this is our first index, and then our second index would be something like this. And this immediately makes this O squared, because we have like a loop inside a loop that depends on the number of elements. So I know it's not the optimal answer, but it will help us. So this will start at I, and we will do j less than nums.size plus j in this case. And last item is 15, miscopied from the example. Oh yeah, that's true. It doesn't really matter though. It's just so we can get some data here. We can add more here, so like 30 or 30, 44, some real big numbers in here. Just to make sure this won't fail. By the way, Jean, really nice to see you here, dude. I hope you've been doing well, and I guess you're from France, right? Are you from France? If not, you know, good luck. Oh, you've just had a game on the Euros. I was watching that actually. I'm not sure if you guys enjoy football as well. And it becomes really easy now. So all we do is literally, if the nums I plus nums j is equals to the target, right? Oh, I forgot this. Nah, just French name. Fair enough, man. I forget that France isn't the only country that speaks French. And then we can return that, right? So we return I and j here. That's it. So if I was to do something like I and j, right? What's this? What's the problem? Narrowing, yeah. I mean, for the sake of it, let's just turn this into an integer and everyone's happy now. I think this will be fine. But this is not going to be less than O squared, right? If you think about it, this is O squared because we have a nested loop and the elements kind of depend on the and the iteration depends on the size of the elements, like each of these. But if we do run this, does it work? I think it should work, right? So let's see. Can we run this? How do we run? Like, how do we run something here? I am confused. Oh yeah, there's a big run at the top. Yeah, we don't return anything here. So what happens if we don't have anything? I guess we just return empty, right? I guess so. Wrong answer. Target is 6, output is 0, 0. Someone said something already. Hello, Anton. How is it going, man? Hi, j equals I plus 1. That is true, yeah. You are correct. Thank you, my man. So that's already helped me out. Okay. And with this logic, it should, you know, we should always make sure that we never go to the end one, right? Yeah, but this is like clearly O2. This is not less than Like this is not O squared. Yeah, so it'll be here. Now, 4 milliseconds, it takes about 43 milliseconds, which is not good. You can see that a lot of dumb people like me actually implemented the same thing. Now, what is a way to speed this up though? Let's think about it. Because we essentially have like a flat array of integers, and you want to get a target. And these numbers could be negative as well, by the way, because it's an integer. So you could have something like, let's not kid ourselves. Let's not make too many assumptions. We can have something like that. Did we kind of... Wait. Where's the description? Yeah. Can we make use of any assumptions here? So we have exactly one solution. That's fine. Exactly one solution, and you may not use the same element twice. So you could create like a product array, I guess, of, you multiply one by every, you add one to every single one of these, and you transform into that array. But it's just the same thing written in a different form. You can have a single for loop. Yeah, having the single for loop is the key here, but I'm trying to figure that out. I hue on single index variables, then increment on every step. No, I don't quite understand that answer, to be honest. Maybe I'm just dumb. So yeah, the idea is to have a single for loop and not two keys, right? Because that's what would make this this will make it more efficient than O squared. But how do you do it with a single loop? I still don't understand the answer by Anton there. Because essentially you have a pointer to the first element here, and you want to know if there exists another element in the list that when added to 1 would give you the target 16. And then you got to do the same thing for every single element. 2 variables for indexes is a key, I guess. I guess so. But sorry, I still don't quite get that, Anton. You might have to explain it in more words, dude. So you're saying have 2 variables. Let's see if we can get a hint here. So I'm lazy. I don't want to spend too much time on this. A really brute force, would you search all possible pairs? Yeah, that's true. Again, it's best to try out brute force solutions for completeness. It is from these brute force solutions that can come up with organizations. Okay, nice. If we fix one of the numbers, x, like we have to scan the entire array to find a number y. Can we change our array somehow so that this search becomes faster? Can we change our array somehow that this search becomes faster? So can we change this array? Can we sort it? Usually that's what it means. What happens if you sort this? Yeah, so if we sorted this array, we have like, let's just copy this. I do wonder if sorting helps. No, but sorting, can we sort this? Like a sorting would still be, quick sort is still O squared. But does it help? Anyway, let's see. If we had this sorted, does it improve anything at all? Gosh, this is an easy one as well. And then we still got the target 16 here. So yeah, if I wanted to actually get 16 from -10, I would have to add something at the very end here, right? I guess. So -10 plus what? We would have to get 26 here. So any value above 26 wouldn't work, right? So we do like, for this key, we would work out something like, you know, the target is 16, so we need to get the target, or the number minus the target. That would give us the max value that we can have. And then, yeah, I guess it would make things a little bit faster if you sorted it. But then you also have the overhead of sorting, yeah, which is interesting. Could you paste the link to this problem? Yeah, man. It's just on the LeetCode page. Yeah, I guess sorting it would help, right? Maybe second train of thought. Without changing the array, can we use additional space somehow? Like maybe a hash map to speed up the search. Ah, I see. Yeah. The answer is always a hash map, isn't it? I get what this means. I finally understand. So, why is the answer always a hash map? This is a meme now, isn't it? So if we were to create a hash map here, so stud unordered map. And then we have integer to integer, right? So let's say this is like the you know, the key in the array and the desired key, or in fact target minus key, right? That's what we want here. And if you haven't figured it out how this fixes it yet, this is it. To sort it, you would actually lose the indices though. So you'd need to sort and store the previous index. Yeah, you would, absolutely. So actually, let's change this a little bit. This could work too, but if we have the value in array, and then we also have the key here, right? Because what we need to get is kind of like, if you have a value, say you have 16 as a target, and you have an array, and you're focusing on the first number, which is 1. What you need to get inside the array as well is 15, right? So you just search inside the unordered map twice, and that's it. Which kind of makes sense, right? So values, let's just put values in there. Can we create an unordered array by, we can transform it, right? Yeah, we can transform it, but I guess we can just iterate for each element. Let's just do it the lazy way. I is less than target. Sorry, this is nums.size plus I, and then we're just gonna like do a values.insert, and then we have nums I here, and we have the index that it is originally, because we don't want to lose that information, because unordered map is basically a hash map, and you basically lose, as John said, you will lose information if you don't store it. And now the algorithm becomes very easy, right? So for every like, once we transform it into a map, we still have to do a second pass on it, but the important bit is that we don't have a values in nums. The important bit is that we don't have a nested if here. So we know what the value is. So now we want to do like autoconst desired key, or desired complement, right? Let's call it complement, and that would be the target minus the value, right? And then we just do a find here. So auto found, let's say we got the values. Actually, we can't do this because we still need the index in here. Okay, yeah. So we do values.find, and now we have nums I here. And we just say, so if we found the value, if the value is not the end, so if this complement exists Actually, this should be complement, not nums here. Come on, guys, you're supposed to be helping me on this. So if the complement exists in the map that we created with all the values, then we found the answer, and it's very easy, right? So if the complement is found is not end of values, right? Yep. We're going to return found.second. As easy as that. And at the end of it, we just return. Actually, yeah, this is I and that. And at the end of it, we just do this, right? How does one know how he achieves senior stage related to this? Stage related? Wait, I don't understand your question, my dude. You're gonna have to put more into that message, unfortunately. Right, so let's remove this because I can't see the freaking message from hide element. Sorry, just a sec. Here we go. Yeah, I think, you know, so you basically transform the values into an ordered map, and then you find the complement. Let's see what this gives us. What the hell? It's an empty. Okay. Right, this should compile now, right? This is like an easy, this is embarrassing because this is an easy problem as well. It should be a quick one to do. Right, so let me just see if I've got everything right. So we've got the key here. The key is the value initial. And the complement, we have the second there. Okay. What if we run this? Now this obviously isn't going to work. Output is 0, 0, right? So we wrote something that doesn't quite work. Now let's see what happens here if we just debug it, right? So I'm going to do the exact same thing. I'm just going to debug it because I clearly wrote a bug and I have no idea where. I could look at it, but debugging is probably going to be quicker in this case. So we insert the nums and the index. Maybe that's something I missed straight away. And we go over all the indexes again as a second pass. We get the complement, which is target minus the current value. And we try to find the complement. And if it's not the end, we found return that. Otherwise, return 0. Okay. Yeah, no idea. I clearly wrote a bug here. So just for the sake of getting this to work real quick. Right. Now let's create a debug real quick so we can see. What makes a senior C++ developer different from others juniors? What kind of knowledge and experience do they usually have? Can you give some example? I'm trying to get some entry-level positions right now. Yeah, first of all, Pietka, welcome to the stream, man. And I guess, you know, a senior developer is supposed to have a little bit more experience, and also in your job you'll get more responsibilities, which kind of means you're doing a lot of code, you're teaching people, and you also have like other stuff like you're architecting problems, you're getting into meetings where you're like designing the solution to something, right? And you're discussing those things. So for me, that was basically the transition. I just started having more of those things. But you shouldn't really compare yourself too much in terms of like the level that you're at. Just what I can say is like try and just keep consistency in learning. Keep learning what you can. A good like thing that I like to see in programmers is how good a person is at learning what they don't know. I was talking to someone about this the other day actually. So real good programmers that I've met and I've worked with, and there's quite a few of them at this stage actually, especially my current place of work. There's people that are amazing, much better than me. They are very good at like beginning to solve a problem that they've never seen before, or work on like a technology that they've never worked on before. And they are extremely fast at getting to that stage where they know what they don't know so they can learn about it, right? because, you know, all of us can actually learn something, but like knowing what you don't know so you can learn the right stuff is a different problem. And yeah, each question only has a unique solution. We are effectively creating a set. I think, not sure, your solution has more memory usage than needed. Also, you could likely have iterated over the iterator of the map since it's stored. Yeah, we'll see that. So you've actually said a good point about having a unique solution. This map could essentially get... yeah, so see, this one is a good example. So I think that's the problem. Because the target is 6, we have 3 here. So it's going to get 3 and 3, right? So it can't be that one. That is a very good problem. So thank you, Gerard. That's a very good... And that's probably what I would find out in debugging. But I'm going to sort this out anyway, just so we can actually start debugging later on. So what does this return, right? So let's add the configuration, C++ attach. The actual debug would be in build, Leetcode example. And that's it, right? Can we do anything else? So let's try and... Yeah, so my problem is that this would actually return a solution, but not the right one, because it can't be the same number. What? My mode, GCC. Okay, yeah, just the wrong mode there. Trying to attach to a process instead of current working directory. Let's just do workspace folder from the root. Why not? There'll be something else that's missing as well. There you go. We're good now. Are we good? Are we good, bro? The program has exited with 0. That is interesting. What? Did I really not build this? Yeah, there you go. So if we go into it, and if I just put something on my return here, we will see that, you know, it will be 0. And then found.second would also be 0 for sure. Like, let's see what it... Oh my gosh, I don't get an actual value here, do I? Storage, data. There you go. Yeah, I can't say. I can't say. I think it will be like 0 and 0 here. Yeah, there you go. Which is not right. Yeah, so it can't be the complement. So we need to put an if here, right? This is very easy. So if we do if complement is equals to nums I, we can continue for now, right? So we don't do the first one. So now this should be good, right? And I do apologize for the time this takes. It's just I haven't done any of this shit in literally like years and years. But it's good to think about it. Right, does this run? Let's see. Wrong answer again. Expected 0, return nothing, right? Let's see why. So if the complement is equals to itself, we go num. Okay. There must be something else. Let's rebuild them. So again, we've done another mistake, which is interesting. It's going to be very good trying to find it. So we create all the values here. And the values are the following. So I've got 2, 1, 0. What? Okay, 2, 3, 4. Yeah, cool. Right, so the first value that we consider is 3. The complement is 3, and it's going to continue. Good. Now the second one, nums should be 2, so the complement would be 4, right? In this case. So we found it. We find the value. And we return 1, and the second, which is 2. So chances are the index is just wrong in this case. Correct. So nums is 3 and 3, target is 6. Ah, yeah, there you go. This is another edge case of our thing here. We did it on the wrong. We did the wrong check basically. It can't be the value itself. What has to be the check is down here because they're the same, right? So it has to be if I is the same as oh, actually it'll be in here somewhere. If I is the same as found second, we continue, and that is it. I would use iterators in the array, iterator in the map. I would use the iterator in the array and find with std next as beginning of the map. Yeah, in this case, it doesn't really matter because like the complexity is the one that has to be low. So it's whatever makes it a little bit faster to develop. If I was doing this in an interview, and when you start to mess with iterators and next, you're gonna have problems, especially with like checking that you've not gone out of bounds and stuff. So you could potentially do that, but I wouldn't recommend it. There you go. So if we submit it now, we got the optimal answer, which is good. Still, some people did a lot better. So can we even use, like, instead of using an unordered map, is there another structure? We're not going to do it right now, but could we do something that would make this a little bit faster? One of the things that I know we could improve is the use of an unordered map here. So this is actually, an ordered map is actually quite slow if you don't have that many elements in C++. So potentially changing this from an ordered map to stud map would make things a little bit easier. Another use would be converting the values, into some sort of array, I guess. So like just a contiguous array where I store, yeah, no, I don't know here. I can't think of an optimal, even more optimal solution. I think we're going to be happy with this, right? So let's move on to the next one. Right, what problem do you guys want me to pick now? So you decided for me. A medium, hard, or whatever. You want me to look at a company problem? There's, you know, Microsoft, TikTok, Salesforce, you name it. So go on, let's see. Let's see on the comments what you guys want me to do. I'll give you guys a few seconds while I drink my Coke. So if you guys have a link to a problem you want me to do as well on stream, let me know. Bear in mind, we just spent about, what was it? Yeah, just under 30 minutes on a very easy one, which, you know, could have been faster, I guess, but at the same time, we'll just warm you up. Any takers? No? Then I'll pick one. If you guys are not going to pick regular expression matching, hard. Anton, mate, you're going to... Regular expression matching, okay. Hard. So let's see how hard this actually is. Given an input string S and pattern P, implement regular expression matching with support for dot and star, where dot matches any single character and star matches 0 or more, right? Or the preceding one. The matching pattern should cover the entire input string, not partial. For example, input is string is AA, the pattern is A, output is false. Explanation: A does not match the entire string AA. So if I have S, A, and the pattern is A star, this is true because it matches the pattern. Okay. This is interesting. Why is this hard? It doesn't sound that hard. It really doesn't sound that hard. I think it's about data structure. Is it? I mean, I could literally just create two functions here. One will be for the start. That would say, you know, car matches pattern or something like that. Now, yeah, I could create a function that would take like one character. No, never mind. Yeah, let's think about this a little bit harder. Maybe it is hard. Exclamation dot means 0 or more of any character. Not a tree. Could be a tree. I don't know. Hello, Candija. Yo, this is Ayub. Hello, Ayub. How is it going, man? Welcome to the stream, man. Oh yeah, by the way, if you guys haven't done it yet, please like the video. It helps me out quite a lot. But I'm just finishing my peanuts, by the way. I'm just thinking about this while finishing them, and we'll start it. So the constraints. The length of the string is between 1 and 20. The length of the pattern is between 1 and 20. S contains only lowercase English letters, which is good. P contains only lowercase English letters. Okay. Alright, I'll put Pino. Yeah, does it need any special tree structures? I'm not too convinced yet, because you can just like linearly go on the string and apply a function to just see if like a character is matching the previous like scene pattern or something. I don't see how this is that difficult, but maybe once I start doing this, it will be. Right, what am I eating? Peanuts, my man. Salted peanuts. Good old peanuts. And Coke Zero, by the way. I'm still not sponsored by Coke Zero. Shout me out, guys, and then Coke Zero will one day sponsor me. I'm going to save a little bit of Coke. Yeah, let's start it. So let's copy the solution thing. It's weird how they like have a class with a function called solution. Very weird indeed, isn't it? Let's remove the previous one. We did it. Let's just fix the bad coding practices. Sponsored by LeetCode. Okay. I mean, we can do some assertions here, right? So we can take all of these things and make them into our test, right? So if we do C assert in here, just for a test case, you know, TDD, let's put all the keywords in here. I think C assert is the one. Now I should have access to assert. Yeah, there you go. I'm gonna assert that solution is match. What was the first one? I have AA and A equals false, or not this, in fact. A non-static member reference must be relative specific to, I have no idea what that means. But we'll find out, right? And let's do a few more test cases here, just so we can see if this thing actually works. So AA and A star should be true in this case. And then we have AB and dot star should be also true. That will be more like complicated things, but we will do it anyway. What happens if we just build this? Gosh. No return statement. Yeah, that's quite literally no return statement. It's gonna make all the tests fail. In function int main, cannot tell member function bool is match because this is not static. And there you go. So obviously all of these things will fail. So we have two strings here. one of them is the pattern, the other one is the string, and we got to pattern match the regular expression that supports. Let's just put the problem in here. So support mini regex for this and this. That's quite literally what we have here, right? Ooh, gosh. And I guess we can have combinations of things as well. So we can have, you know, very complicated ones, such as something like, you know, B star, and then we have dot star, and then something like C star, right? That could work too, which is really a pain. So this is where it becomes complicated, I guess, when you actually figure out that these things aren't just a simple like function call to solve it all. You do actually have to probably turn this into something a little bit more robust, right? So if I was doing this naively, what would I do? I would probably pick the first part of the pattern. So like pick a unit, a pattern unit, which will be this, like this one here. And then match as many, like lazily match as many things as I can. Oh, sorry, to that. So for example, if I had the string, you know, b, whatever here, and then c at the end, I would find out my first bit of the pattern, which is B star, right? This is a unit here because B, yeah, B would be a unit, but then we have star after it, which means it has to be preceded with something. And then we match it, we lazily match as many as possible, which will be like up to here. We get the index. So we would have something like a map, right? A map where, or not a map, but a vector, right? So we have a vector where we have like tuples inside the vector, and then that would be something like this. And then we say like where it is, like all of this or something, right? And then we do the same thing for the next one, next unit. So the next unit here would be dot star, right? Because again, we have a star here, and there's a pattern emerging. Whenever we have a star, we must have something, you know, before it, right? So we have that dot star here, and that would match as many as possible, right? Which would be, you know, in this case, it would be all of this. But then it also includes C, which is the problem, because this will match the C's, which might not be a problem, right? I mean, it might not be a problem at all. Which, yeah, I mean, it will be a problem actually, because this should match the regex. Oh, what the hell? So if I just did a yank here, paste there, remove the C's. Oh, do we leave the C's? Yeah. Yeah, see, if we matched it in that way, then we would not be able to find CCC or C star in this case, which is a shame. It's a shame indeed, because that would be empty, right? So we wouldn't have a match here, which, and you know, theoretically, if we went ahead with this sort of algorithm, we want to make sure that every single element in this vector has a match, has a valid match to it, which, yeah, is a problem. It is a problem indeed. And this is where we have to mess with like actual, I guess, indices and stuff. So I think we will look at the hint for this one just to get us going, to make sure we're not doing anything weird. But basically, what we want our algorithm to kind of have some flexibility in matching as well, because when we see something like this, where it has lazily matched the whole string, or more than it needed to, we want to be able to like remove some of these and see if it still matches. So for example, we want to be able to see like what happens if we stopped right there. Would this one have a match if we did that? In which case, like, yes, it probably would, yeah. Or hear me out, right? So what if we match the whole thing instead? So what if we, we did B star, not just the start of the string until the end of the first match, but everywhere. So we found all the possible ones. So it could be here, but we could also have like BBB here as well, right? So we found this one, and we also found that one. And say we also found another one here. There, right? So we found all of these. And we did the same thing for this one. It will be a little bit weird because we would find, the whole string at first, and then we would find, every possible substring of this basically would be like a match in our case, which is a little bit inefficient, I guess, right? But, it would be an option. We have like every single substring of this would be a match here. And this would be included in there as well. This would be in there somewhere. Say we found all the matches like this one. And then we do the same thing for C, right? So C, we would find, maybe we have like some C's in there as well, right? So we would find, dot, 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 whatever comes before, and then we find that double C, so 4C somewhere, and then the 4C somewhere else, right? And let's just imagine that these things aren't actually the strings themselves, but a start and an end to the pattern. I'm just putting the strings here so it's like easy for us to visualize what we want to match on. But this one here would represent like this first match. The second here would be representing the second match, and then we have some more in the middle as well, right? Something like that. Let's just put a dot, dot, dot to represent that. Now the question is, out of all of these matches, can I pick a subset or one element of every single one of these such that the element we pick from here, the elements we pick from here, and the element we pick from here would actually span the whole string, would partition the whole string, right? So this is why this is a difficult problem, because naively, you can't really solve this. But when you actually think of the first solution that comes to your mind, like the one I just thought, that would work, by the way, it would 100% work, and we're going to definitely attempt to do that. It's actually very difficult to implement, and that's why it's a hard problem. But I would say if you're in an interview or, at the first stages of like a tech interview or something like that, don't go straight into coding. Do what we did here, where we actually kind of like analyze the problem and discuss a possible solution until you get something that would work, and show to the interviewer what you would do before you actually start coding. Because just by doing this, I've showed the interviewer that I can think about the problem and I can solve it in like, at least in a brute force way. It might not be the best solution, but it would work if we actually went ahead with it. So yeah, just bear in mind. But as I said, this solution is good. We're going to try and do it now, but it implies a lot of things. For example, we need to have like a structure or something that will, let's put this into a namespace here. We need to have that structure that will imply the beginning and end to a match, right? So let's do that. So we have a struct a match, which would be something like a size t begin and a size t end. I mean, this would just be like the iterators to a string, right? So we can just do that, I guess. So std string, is iterator a thing? I'm pretty sure that string iterator is a thing, right? So we can just use an iterator to the string element. There you go. So a string has an iterator type. Okay, so const iterator. Yeah, we can probably use that one instead. So we have the begin and we have the end. And it's not a size t, this should really be a string. Now, we're going to need this to represent each of our little thing here. this whole thing is a vector, right? So this is a vector of the split pattern. Split unit patterns, pattern units, right? Where in this particular case, we're just assuming that, you know, we have units like this one. So if you have a star, there will be something before it. If we have a dot, it can be on itself. Or if you have a star, you know, it has to have something before it. You can also have, you know, AAA down here. So that whole thing would be a pattern, if it makes sense. Okay. Isn't your match just a sort of range? Yeah, so it would be a range, yeah. So it's a range. I'm just doing it with strings here because the problem actually just uses strings and I don't want to mess with ranges, conversion ranges here. Range conversions, that's what I mean. Now, it makes it interesting if we have something like this, though. I haven't really figured, yeah. I guess that would just be on 1. Is that one of the assumptions that we have in the problem? Let's see. Let's read the problem again. Oh, fuck off. So, assumptions. P contains only lowercase letters. Good. And dot and I. Okay. It is guaranteed for each appearance of the character star, there will be a previous valid character to match. Okay. Good. Yeah, so it doesn't seem like it gets too complicated. I was wondering, like, what if it wants us to support, like, brackets where we can have, you know, essentially something like, I guess, like this, right? We don't want to do that. And it doesn't seem like the problem asks us to do that anyway. But yeah, we have to match character by character here. So let's try and do it, right? So it seems to me like we really just want to split, or we want to find all the stars and get the units before that. So the array for this would look something like this, right? So the pattern array would be like, you know, B star here, and it would be something like a dot star there. And then it'll be C star here. And then after that, we will have A. We would have A. We would have... how many do we have here? 4, 5. So A. And then we have A star at the end, right? This is what we kind of want to turn this into. Because then we can kind of do a pattern match on these things, yeah? Yeah, so... by doing this, we will find... oh, I guess we want to actually put all of these together. In this case here. Just like that. Yeah. And then we do like an std find of A in that one. And then we can find it wherever it is. Okay. Right, and now we have a different structure. We have a pattern array. Can we somehow represent a pattern here? So we have a struct, a pattern unit, right? So if we have a pattern unit here, what is that? We have the string for the pattern, for sure. And we can have something like, okay, pattern unit, the string for the pattern. And let's create an enum just for the sake of it. Enum class, pattern type. And then this is where we put like the dot or whatever. So we can have something like a dot, which would be any car. And we can also have star. What does star do? Is just any number, right? And then a naked one. Just a string. Something like that, right? I don't know what to call these, but I just want to start somewhere what we want to do with them. Like the differences, basically. So this would be the any character dot, and this will be the star. Let me think about this. What's a good name for the star? Recurring? No. What do they call it in the problem? Matches 0 or more. 0 or more. preceding elements. I'm just gonna put any here. I don't know if this is the right name, but and then we can have that in here. So we have a pattern or pattern type, which is there, and we call it type there, right? It's just gonna make it easier for us to do a switch case later on in here. That's why I'm doing that now for the sake of explaining. So yeah, I mean, in this case here, we would actually go further, and this would be something like, you know, B and what is it? Any, right? Any in this case, and then we're gonna have dot here and what is it? I guess it will be empty string, any character, right? Yeah, any. Sorry, this is a bad name actually. So one more. 0 or more. Any car. Let's just actually name these things properly, right? So in this case, we have B star, which would be 0 or more. Then we can just put a dot in here for the sake of it, but we can do something like any car, and this will match to any character. And then we have C and something like, was it 0 or more, right? I'm already getting confused with the namings that I created. And then we have AAAA, and this is naked pattern. And then at the end we have a 0 or more. So we're going to convert this whole thing into this, and then we're going to do a switch case where we actually decide, where we actually, you know, given the pattern and what type it is, we're going to get the functions, all the matches. We're going to get an array of all the matches. That's what I'm trying to do. And then we can transform this into this map here, where we have like B0 or more, and here are my ranges to it, right? This is what we're going to do. So let's begin this kind of skeleton code. It's not the whole solution, but it will help us get there. So let's do that. Right, so we want to we want to convert the pattern, right? So the patterns, I guess, would be a stud vector or stud pair, and then we have std. Oh no, what did I call it? Pattern unit. Pattern unit const patterns, or transform, or convert, or get patterns, I guess, yeah, from string, or even better, string to pattern. Oh, you pass p to it, right? So this is something we want to implement. Why is vector not here? Because I removed it. Let's also sort this real quick. Okay. Vector should be up again. We want to implement. And once we've got that, what do we want to do? Just so we can have a full plan of the thing. So we want to get the matches, right? So now we want to get all possible matches per pattern, right? So it'll be, you know, at the end of it, we're going to end up with like an unordered map. I'm not sure if this is going to work actually, but you know, pattern unit here, and a vector of a pattern match, right? There you go, vector of match. And that will be get possible matches. Get all matches, I guess. And then we're going to pass in the right. This is actually going to be an integer, a for loop, right? So I guess for each pattern, auto const pattern in the patterns here. We're going to create that, I guess. Let's just put a string for now. I know that we messed up there. No, we haven't messed up. It's just because like we're going to have to create a hash for this, and I don't really fancy doing it. I'm just going to keep it here for now. It's not going to compile until we do that, but yeah. That's the thing with an ordered map. But anyway, so, and we store a vector of matches, get all matches. This can be const for now, because in here we're going to do, you know, matches dot insert, and then we're going to put something like the pattern, and then they get all matches for that pattern. So we've got the pattern and the string, right? Or S in this case. That's what we're going to do. And by this thing here, now we should have all possible matches for all patterns, pattern units, right? That's what we want to do. You know, but the thing is, at this particular point here, let's think about this, yeah, because if I'd stored it in a map, I actually lost the index information. But the thing is, I don't actually have to store it in a map. I can just do a vector in here, and instead of this, I do a pair of this and another vector, right? So that should work. So pattern match, there you go. Something like that, right? And instead of insert, I'm just going to do a pushback. And that should really be it. Now I have like all this array, all this thing here with all the possible matches. And now the cherry on top would actually be, you know, find the correct partition, which is the hard bit. So as an algorithm, like considering something like that, right? So if we had this, let me just indent it here so we can work with this a little bit better. Consider the pattern matches vector. This, what we want to do, find a match for each pattern where the combined matches form the string S, right? This is the difficult bit. So we're working backwards. So we have all the partitions, all the possible partitions. We want to do basically like get an element of here, an element of here, and an element of this one that will form the entire string. And that is very difficult. Very, very difficult indeed. But, you know, it's something we can do anyway. So let's do it anyway. But anyway, first thing we can do, which is actually quite easy, is string to pattern, right? So let's create this function here. So we'll have a function called what should it return? Std vector of pattern unit, and then we have string to pattern here, and we just take a string const, in this case pattern p. I'm just going to compile this real quick to get my IntelliSense up to date, just to see how the problem is. Namespace std has no vector. I think not though. We have vector in here. You know, I realized it got really complicated really quickly, and I realized that every time people stop talking in the chat, because usually they're not following the problem. But let me know if you guys have any like suggestions on how to make this simpler, or if you found it too complicated. I'm happy to like explain to you how this all works. But yeah, this is a hard problem, and you can all blame Anton for for you guys losing the interest. We should have picked a medium one. But the question is, why do I have no vector here? Std vector. Sorry, it's alright, Anton. Surprisingly enough, you're one of the only two people watching this, but we're gonna finish it anyway. We're gonna get very far on this. std vector anonymous pattern unit warning no return statement in function. Yeah, there is none. Now we should stop complaining. No vector should disappear. Why is my IntelliSense just being complete rubbish? I don't understand this. So anyway, this is what we want to do, right? This is what we want to do, and at the top there. So let's think about it. I mean, this isn't very easy either, to be honest. Even turning the strings to a pattern is actually quite difficult. Sorry, try to reopen VS Code. Yeah, I could reload the window. Could reload the window here, but I'm not sure if that makes a difference. Yeah, things are happy again. I mean, things aren't happy, they're just not sad, yeah. It's just not complaining about the stuff he hasn't found. Oh yeah, there you go. It worked. Thank you. So let's think about this. So we've got this. If we just use iterators here, right? So we start at the beginning and we go 1, and then we see, is this a star? Is this a dot? No. And if it's not a dot, we can keep going, because it's probably just a normal pattern like this one here, right? So if it's not a dot or a star, no special characters, we keep going until we find something like that, right? If we find a string, if we find a star here, then we want to... Wait, let me think about this, because actually we could just split on the stars. And if we split on the stars, we can further, like, we're going to get something like, you know, an array with a string B, a string dot, a string C. And if an array is not size 0, we have to split that further by, sorry, if it's not size 1, we have to split that further by just removing the last character. And then we have the whole thing, right? Yeah, I think this is probably easier than anything I'm going to do with arrays. So why not? Let's try that. Let's try that. So split on string C++. Oh, there is no split on in C++, which is interesting. So I'm just gonna grab a quick ready-made solution here for us guys, unfortunately. So substring you can find. Okay. Yeah, that's one of the things I hate with C++. I absolutely hate how it hasn't got some of the things that we take for granted in other languages, so you have to do it yourself. But let us just find a quick and easy thing we can just copy and paste. So namespace string s, okay. That was a little bit too difficult, so I'm not going to go for that one. So get words, that's not what I'm looking for. I'm looking for just the split on and anything. Split on character. String C++. Splitting a string by a character. Okay, that sounds good. I'm happy to go with this one. So we have string stream. Let's just copy this. And put it here, right? Because this is a helper function. So we have std vector. Ooh. Vector of std string. Split on. And then we have string const here. Input. And then we have a character C. That's all we're gonna do. And let's paste that there. Let's apply some formatting. I do have to include string stream in this case, which is a bit annoying. S stream is actually there. Yeah, that's correct. Actually, let's do a sort here. We already have that test. So std get line. Where's get line from? It's from IO, right? Stud IO. IO stream. What? I'm pretty sure it is from IO stream, but I don't know. Anyway, so std get line, we have in here, and we have the character C in this case. Seglist push back, and then we just return seglist, right? Seglit, indeed. Seglist. And what is the issue here? std get line from in segment. No, this is supposed to be a string stream, isn't it? Get line into segment, we'll push it back to segment, we'll split on C. So this is supposed to be a string stream. Test, yeah. There you go, that should be a little bit better. Ooh, what did I do? That should be a little bit better now. Right? Or maybe not. So S-stream is not a member of std. OS stream, yeah. Output, yeah. Let's... Or is it input stream? Let me think. Wait, we're getting input from here, so it's iStream, right? Or is it iString stream? Oh, it's just string stream. What am I doing? String stream. Wrong type overall anyway. This is an output and input string stream now, so this should work. But anyway, all of that so you can get split on function. You know, hello Python programmers. You're probably watching this and laughing in Python programming, which is, no, I don't blame you. But we're in C++ now. But anyway, so what I was saying is we can split on the characters. Sorry, on the asterisks, get all the things that are size 1. I guess size more than 1. In this case, like A would be one of them if we have this string here. And we're going to split it further into something like this, right? In the end, we should end up with with something like this, where we also we know exactly what the star was working on. So dot is nothing special. We shouldn't consider dot as anything special in this case, because it doesn't really apply to the previous element. The only thing that does that is star. So that would be good, right? So std vector of std string in this case would be first, what do we call this? Split on star, right? Split on, and then we have the string itself, the pattern, and we're gonna do this. Okay. And now further to this. Ooh, what am I doing? So const goes here. And now we have to do a second pass where we are going to basically have a result vector here. I'm just going to do this very quickly, and I don't really care about the coding style here, to be honest with you guys. I just want to get this done as quick as possible, which is still going to take time. But we're going to have a result there. If I can spell it, result. And we're going to for loop on each one of these and basically copy all elements. Ooh, that was not a good line. So for int, for element, or for pattern, in split on star, or just str, right, I guess. If the size of, or str.size is more than 1, what are we going to do? We're we're going to insert two things. So we want to insert the pattern up to the last element. And then we also want to insert the last element by itself. Right? This is what we kind of want to do. Maybe this is not going to work actually, now that I think about it. Because then we would have something like this, where we will kind of split, you know, we're going to have a B here, and we're going to have dot here, and we're going to have C here. But then we can have A. But where are the asterisks, right? Before we split on things, we also have to put them back. Which, yeah. Which is a problem, isn't it? Because there will be... Yeah. We can't lose track of the asterisk, that's what I'm trying to say. So we've, like, with this approach, we've lost track of the asterisk. So we also need to put them back somehow. I'm pretty sure that there is a function called find if in C++ that returns the iterator to the first found iterator. But there's also a variant of that where you can take a begin iterator. So we can work on the string until we find the asterisk. We save that. And then we continue from there while we split things, right? That could be an option for us. I mean, we can also just insert them right in the middle because we know they're always going to be in the middle when we split them, which is fine. Yeah, let's do that actually. That's a little bit easier. So I'm going to assume that the asterisks always happen in the middle, which they do, I think, if we split on it. So like if we split this string, we're going to get B, and then dot, and then C as individual one-size arrays, and then A 5 times. But they're always in the middle or at the end, which is a problem. Oh, yeah, they could be at the end as well. I don't know what happens if they are at the end. This is turning into something like more difficult every time. And I guess that the title does work in this case. I am struggling. But I'm also trying to stay hydrated, which is what you guys should be doing. Right, let's think about this. I mean, yeah, I could just check from the string if it was at the end, right? We can just do an ugly solution here just to get this work going. And I don't mind. So we're going to go for the first element. So we're going to insert. If the size is more than that, we insert that. Else, if the size is 1, okay, yeah, let's do this. So if str.size, what am I doing? str.size is 1, then I am simply going to insert the string with the asterisk. So I guess insert the string or the 1-char pattern right into my result, and this result should really be a pattern unit. So I get my result here dot push back, and I can do pattern unit, something like pattern equals whatever it was, str, and the type is going to be, what was my type again? Pattern type 0 or more, right? Zero or more. That's the very easy case. And then we obviously continue because we don't want to keep processing it. If we stop there. But now if the size is more than 1, what do? We want to result.pushback. Actually, there's another edge case here. So if the string.size, or if the string is just simply equals to dot in this case, right? We want to insert a dot pattern, which is the string, and then we also have any car, right? And then if the string size is more than 1, we know that we have to split it. Yeah, we know that we have to split it. Okay, yeah, this is getting difficult, but we're going through. We're going through. So we are going through. So we are inserting a pattern unit here, where the pattern is going to be equals to string str.substring, I guess, and then we got 0 to, I guess, whatever the last one is. So std, oh sorry, str.size -1. That's the pattern for us, and then we also have the type here, which is just naked. Yeah, pattern type naked in this case. So we've inserted the last element up to the last character. Now we have to figure out whether or not the last character should be a star as well. No, we did that at the end. Never mind. All right. So, and now we also do another insertion in the same thing. This is getting difficult, but this is what I'm doing. So if we get something like a list where we have some elements here, and then at the end we get something like this, what I'm doing is I'm converting this into that list, and also A, and A here, right? Or A star. That's what I'm doing here, right? Because this is the pattern that was in it originally converted, because this would have been obtained from something like this. So, you know, whatever the pattern was, A star, and then, you see? So we're just like basically sanitizing this. That's what we're doing. So, yeah. I can't help but to think that there must be like a much easier solution than all of this that we're doing here, but at the same time, we got going, and we're gonna keep on doing it. So we got the result that pushed back. Of course, it wasn't going to work with that. And then we invite the next one here, and the pattern type is 0 or more. That's what it would have been. Okay. And obviously, this really only works if I do a take here. So like this should really be running from the 0 to the last -1 element, right? Maybe we can actually use the ranges here to just make things easier instead of just doing. Let's do a take here. So take. So this is just going to allow us to actually say, you know, take all of them except 1. So where is take again? I love the documentation in C++. Like, look at this. It's beautiful, isn't it? So ranges, views, take 6, right? That's what we do. And we want to put the header ranges at the very top. split on star. So we do std ranges view, or views, right? Yeah, views. Take 6, right? Yeah, so we do split on start. What is pi? Pi is a context per character array. Okay, good. And we're gonna take, you know, split on star dot size -1. Okay. Okay, so this should take all the elements except the last one. The last one is going to be special. We're basically going to do the same thing here, which is annoying, but oh well. We can split this into a function. So what do we have here? If the size is more than 1, yeah. So at this stage, we've worked out most of the patterns into pattern units, so we know what types they are. But we kind of need to just do the last one now, right? So I guess there will be a function to do the last range. So let's see. So C++, or do we just do it here? Yeah, I guess we do it here, right? So if we do the size of, so split on star dot size was more than 1, last string is going to be split on star dot last, or back, right? Yeah, back should be a pointer to that string, or a reference to that string. And we can do the same thing as we did here, which is annoying. Like, we're going to have to do the whole thing here, except this changes. Which is not ideal. Yeah, we don't need to continue here. We just want last string here. In fact, can I just do a str? Oh no, that's a lot more matches than I wanted to. No, 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 no. No, no. Don't replace any of these, please. Okay, so we already have that change. I missed one up there. No. But yeah, that find is not doing me any good, so let's just do it manually. Vim was not helpful to us in that case. Okay, so we have last string here, and then last string here, and then last string here. Yeah, I mean, if the size was more than 1, what we want to do is essentially see if the last element was a string, sorry, was a star. So if some reason we had something like, you know, whatever patterns in here, we want to check if the last one was a star, because if it was, then it means we, you know, the last pattern for us here, the E should be a star. Because also if we split on this and it's nothing, then I'm pretty sure that we probably wouldn't get the last element at the end, right? If we do a split on, I don't know. This is getting too confusing, guys. I need to close the door. 1 second. Be right back. I am back now. Hello Al. How's it going, man? I'm glad that you've joined us on this. It's extremely hard regex implementation Leetcode because it is difficult. I thought it wasn't, but then I started doing it and I realized that implementing regex is actually a very, very difficult problem. But oh well. Yeah, my question is, what actually happens if we have a star at the end? Because like it will split on this, so we're gonna get this array, but do we also get an empty array at the end? That is the question. Because if so, then yeah. My hope is that we do, right? My hope is that we actually do get an empty array at the end. So I can kind of just come in here and say if string is empty, so if the last one was empty, then we want to sanitize, yeah. Then we know that the previous string should be a star, right? So the previous like character should really be a star. Gosh, this is getting difficult, but yeah. So just to summarize here, we've got a pattern here with a string that looks something like this, and then what we want to do is like we want to convert this to an actual type that we kind of know. Like we can see that it's a B 0 or more times, is a dot any character, or is a C 0 or more times, or is A just naked as it is, we just find A matches, or that. Link problem, please. There you go. I will be very surprised if you do this in 10 minutes. This is it. Sorry, I've been in and out. Are we implementing a parser plus tokenizer for regex pattern? Yes, we are. We're in fact doing that, my man. Which is, I mean, I know that, you know, implementing a parser for a very simple regex is kind of difficult, but we have a plan anyway. So we're gonna keep working on the plan until we can't anymore, until I fall asleep. But yeah. This will be like the tokenizer, basically. So we're tokenizing the pattern. And yeah. And I've not done anything like this in years, so I'm confused. Could you not just loop through all the characters, catching the previous character, and then if the current character is star, then do current plus last in special case, otherwise only last was the token. Not quite, because I want to be smart about finding the actual matches. So what I want to do is I want to get a list with all the possible patterns, such as this one here. So we have B 0 or more times. But I also want to have the naked ones, right? So I can't just iterate for each of the characters, I guess. Or could I? Yeah, maybe you've got a point. Because we're then going to have to partition the whole string. So once you have like the actual patterns that you have, you need to find all the possible matches, and then out of all the possible matches, we're gonna get the partition that makes up the entire string. So a simple lazy match won't quite work because of this case here. So for example, if I have this pattern, it's gonna match, you know, all of this, and if I have dot star, it's going to match just like all of this and leave no space for the end ones. So it's a little bit more difficult than that, I think. But it would be nice if it wasn't, though. It would be very nice. Maybe you're right, though. Maybe you've got a point. But yeah. But either way, I'm still struggling on the tokenizer thing here. So if we split on the stars, question is, do we get an empty array at the end, or an empty string? So yeah, I guess I could check the last string, right? So if I do split on star dot I guess we have to check the size. Split on star dot size is more than 1. Yeah, so we have last string here, and I want to see if the last string is empty, then in this case we kind of know we had at the end, which means that we, yeah, this is messed up. Which means we have to change the pattern unit to be which means we change something like this to this. Gosh, this is messed up. Oh my god. Which is fine if we have that, but if we don't, and then we kind of return here, right? Return at this point. But if we don't, we just kind of have to split the thing, innit? Yeah, so if we say that if the size of last string dot size is more than 1 in this case, then we do the split here. So split AAA into, wait, let's think. Oh no, because in this case we know the last string was not empty, so we don't have to do anything. So we just insert naked pattern AAA here. Okay, right, we got this. Just had to think a little bit. So the result dot pushback pattern unit. The pattern is going to be what? Last string dot substring 0 to last string dot size minus 1. Oh no, wait a second. We are actually modifying the previous one. Gosh. So actually what we're doing here is like doing this dot back, which returns what? Yeah, this dot back dot type is going to be equals to we have to replace the item now in this case. This is getting more and more difficult. So the previous last is going to have to be replaced with the new stuff, which is fine. We're going to do 2 of these basically. We're going to insert it twice. The joys of Vim. I'm pressing you by mistake. Okay, let me think about this. Because then we get the previous last, we move it out. Is there a pop function in the vector? I don't think there is, right? So can we do result.pop back? const x per void. Yeah, no. We have to do something like this. So pop back. Okay, so we copy and replace the last one with new stuff. That sounds a little bit better. So previous last is back. So what's the issue here? Pattern unit has no member substring. Oh yeah. So it will be that, and it will be naked, and then we can do another one here. But this time, we do the pattern. But then we got to make sure that the pattern is actually modo, right? So if the this becomes more and more difficult the more we think about it. You see, so this only works if the previous last pattern has size more than 1. I mean, if it has size 1, we simply replace it, right? So we simply just do something like result dot push back something like this. So type is going to be equals to pattern type 0 or more, right? Because we know it's empty here. Okay, now if the size is more than 1, I guess it can't be 0. The size will never be 0. Right? Yeah, because that's part of the assumption of the problem. You always have a valid character before the star, so you'll never get an empty array right in the middle of things. But which is good. Yeah, if the size wasn't, then we have to actually substring things. So instead of that, we just get the last element. So back, right? The pattern is going to be the back, and then we're going to have something like 0 more. Why is previous last not working here though? No conversion from characters to string yet. That's fine. We can just do this in it, and that should work. Yeah, I mean, not a fan of how this function turned out, but let's see if it works at least, right? And if the function works today, I'm happy to to continue this, but I'm not sure if I'll be able to debug this the whole day here. Return if the last character is 0. Return result. We have an early return there, so we have an early return here as well. And that is if we had more than 1 and it was empty. If it wasn't empty, that's the thing though. Yeah, if it wasn't empty, we just add it as is, right? That's the thing. So if else, we literally just insert into result. The pattern that it was last string, and the pattern type would be naked type, right? And then we can return the result here. Gosh, I mean, if this works first time, very interesting, but I don't think it will work. We don't have this function implemented yet. Let's just remove that. Let's just put a breakpoint in there and see if we can do some of the if we can actually like parse some of this stuff, right? So what's the string that we had in mind? for the pattern. Because we've essentially implemented a tokenizer in an hour, which it probably means it's not going to work, but we will try anyway. So I just want to put this in here. So which one is the pattern? This one. Now, it will be interesting if it does work, though. Okay. So actually, let me just put it straight in here. So we're straight up gonna call the function with the pattern thing. I should have knew it was gonna be a tokenizer as soon as I saw the problem. So let's see if this worked at least. So if we debug it, okay. We actually have something. We do, we have something. So we've got B, which is 0 or more. And then we have dot, any character. Ah, we have a problem here. Oh, of course. We did not account for dot 0 character, 0 or more. So we've got to fix that in a tokenizer. But that's fine. Then we have what? We have C, 0 or more. And this is the problem. We have AA. So this last bit did not work, which is fine. Let's see why we can't do it. So first of all, we have dot 0 or more, right? I think there is nothing to do except just add another one here. So any 0 or more. Any car, 0 or more. Something like that, right? Yeah, so if the string was that, instead of any car, it should have really been any car 0 or more. Right, that's the thing. Yeah, but then we also have the problem of like ending up with a dot in the middle here. You see? Yeah, this is also a problem with the tokenizer. Now that I think about it, it's just getting harder and harder. So if we have a dot in the middle, we have to split this into two patterns, right? So we have to split this into like the A's and then the dot and then the A's again, which is fine. There's just another iteration of the whole work that we've done here, but let's just fix one thing at a time. So if we have a dot on its own, is it any 0 or more? I don't think tokenizing is a good way for this stuff. Yeah, I'm starting to think the same thing. It's just getting more and more complicated. Maybe Jean is right. Maybe the best thing to do would be to just iterate over the string. So we get like, we get this string here, and then we see if the next character is a star, and then we end up with like just lazily getting as many B's as possible. And then we get a dot and a star as well, and lazily getting as many characters as possible. But then once you've done that though, there's no way, like once you see this in your pattern, that's why I think tokenizer is necessary in this case. Because once you have this pattern here, where we have a dot star, it's going to match whatever string comes after, and you're not going to get to match any of this. That's the thing. To iterate with a peaking is the easiest way. To iterate with a peaking is the easiest way. I guess I don't quite get that one, to be honest. But if you're, yeah, if Al, you're suggesting just like two iterators to lazily match things, this is why I think we need tokenizing. Just because of this pattern here, the dot star, this is the issue. But needless to say, I failed the interview in this case, right? I did not get it done in like an hour. But I'm actually going to continue working on this because I'm interested to see if I can do this, to be honest, and I think I can. It will just take me like a good 3 hours or something, because once I tokenize everything and I have this here, which isn't that difficult to actually do once you have like all the patterns in your mind, it becomes very easy for you to get the next step up, which is the actual vector with all the possible matches, not just the lazy match. You need all the possible matches, so you can then at the very end get the correct partition from each one of these that will form the whole string. C can be resolved by peeking ahead in the pattern, because C there should be used as a stop for the matching. I see what you mean. Yeah, I see what you mean. Yeah. Oh yeah, I see what you mean by peeking. That makes complete sense. I don't know why I didn't think of that. So you just look ahead, so you know, like, you should stop or try to stop whenever you encounter a C. Huh. Yeah, that could work. That's a good suggestion, Al. So it goes to show you guys. This is not the best way to do things. I think this tokenizing way would be good if you wanted to find a minimal string that matches it, because it should find the whole string. Well, let's see the problem though. I think the problem did say you should find the whole string. The matching should cover the entire input string, not partial. So I guess the peeking would still do that, right? Would still cover the whole string, not just like a partial match. Yeah, I'm not sure, Al. I'm not sure if that would work now, you see, because you should match the whole thing. So if we did a peeking thing where we stop on the first instance that we find, then we would not match the whole string. And then you just have to keep going for the peeking iterator there. But at that point, you're doing a tokenizer anyway, because you're going to have to do every sort of edge case that goes around there. Yeah, interesting. It's good to think about these things, though. What did the hint say? Ooh, let's see on the discussion. Also, maybe do precedence as well. So anything with star can be matched 0 times according to the rules. So you need to check that last, but in the correct order. Yeah, so there's that as well, which is why I think that you might have to do some sort of tokenizing anyway, just to get the possible ones. What the fuck is the pattern? There's not even a specification. Here's the problem example. This, okay. Here's the output, AB, output false, expected true. Okay, people are very much struggling with this as well. But yeah, needless to say, I did not get this done in an hour. How long does it usually take to get this? So for language C++, do we have any notes here? I don't want to look at the solution, because I'm gonna be very annoyed when there's like a very easy way of doing this. But that's it, guys. I'm gonna call it here, guys. I'm actually very tired and it's already 10. But it has been fun though. We've managed to do an easy problem, and we've got stuck, or I got stuck in a very hard problem, because maybe I'm over engineering the solution a little bit by tokenizing things. But I still think that it's necessary, just because of the requirements here. But yeah, thank you all very much for joining. And if I do manage to solve this problem in a few days, I will probably post it somewhere, and I'll let you guys know on Discord. Just because this is actually a very interesting problem. Like, it covers everything. If you want to do it in a tokenizing way, it covers tokenization. It covers a little bit of regex. And by doing so, you can see why regex is quite expensive, because there's a lot of operations going around this. This seems like quite a tough one though. You would need to implement a state machine with tokenizing, I think. And I agree completely. You know, what you guys said about lazy matching with iterator is fine if you want to get the minimal match. But the problem specifically says match do the maximum match for the entire string, not a partial match, which means that you're going to have to consider every match and then find, the maximum one, which makes this a tokenizing problem. And that's why it's a difficult one. But I'm going to continue working on this maybe tomorrow, and I'll let you guys know on Discord. Bye. Bye-bye. Thank you all very much for joining. Like the video and have a good night. Bye-bye, guys. I can't do this anymore.